All right, so let me start with a story. Once upon a time, there was a farmer. He has to manage a big farm and he used to sell milk to customers. Now, the problem with that is he had the cows for milk production and they used to roam around all day. So he has to control them. They eat large amount of food. If they fall sick, you have to take care of them. And when they get old, the production goes down and you need to replace them. And they were expensive. Just like our old servers or virtual machines where your applications are running on them. When they get old, you have to go and replace them, right? So what farmers should do? So he discovered that rather than using these big animals, he should start using smaller ones. Instead of cows, he started using goats and sheep, right? They were small, so they take less amount of food. You can control them easily. You can put them into constrained environment. If they fall sick, you can easily replace them because they are small. What happened with that is their demand starts to rise. And the demand was variable also because in some season you might get more demand for milk and for some season you might get more demand for eggs, etc. And that's the introduction of containers. And the major thing which containers run today is on Docker. So that is what this is explaining. All right, so how does he solve that problem when he cannot control all those small animals? What he does is he decides to hire a cowboy named Kubernetes. He knows how to manage this large scale herds and the containers. Now he has some tools in his pocket to do that. I'll just briefly go over it. We'll not too much deep dive into that. Basically what Kubernetes does is you do have a cluster where you have a control plane and you have nodes. The nodes is the place where most of your containers are running or your applications are running. Control plane is the one who manages those nodes. Now within control plane, you have API server. So all the interaction with the nodes happens via API. It also have etcd, which is high available key value store to manage those nodes. There is a kube scheduler so that it can spin up containers. Kube control manager, cloud control manager. These are mostly components of control plane. On nodes, you do have kubelets and kube proxy. So kubelets are the agent which are continuously running on those nodes and monitoring your pods. And we'll talk about pods in the next slide. Also, the kube proxy is the one where you manage all the network rules. So this was high level to it. Okay, let's deep dive into what exactly Kubernetes node components are. So now the smallest unit in Kubernetes is called pods. Basically, you want to keep your animals in a constrained area. And then there can be one or more animal, just like your pod can have one or more containers. Typically in Kubernetes, you do not want to have multiple containers in one pod unless there is a reason to it. For example, if you want your application to be running and then also a logging container running, reading from the application, and then sending that log data outside. So in those kind of cases, it makes sense to group containers together in one pod. But otherwise, you would always want to keep one container, one pod. So let's do some practical with this too, rather than just talking about it. So let me open this. And I did my CKD certification, and this is my repo for that exam. I heavily used Catacode, where you can spin up Kubernetes cluster for a while and practice, and then you can, it will spin it down after a while, and then you can do it again. So I did spin up one. Hopefully it stays there for amount of our presentation, otherwise we need to redo it. One thing I'm going to do is there is a command which is called Some people call it kube control. Some people call it kubectl. I like to call it kubectl just because it feels fancy. So I'll just give the alias to it. Basically, it helps us to run all the Kubernetes command. And this alias means I don't have to type kubectl every time, and I can just type key. Right, so now if I say get pods, there. All right, so let's talk about pods. So everything or every resource in Kubernetes can be defined in the YAML format, right? So let's say if you want to spin up a basic pod, it can tell you what kind of resource it is, and you want to spin a pod here. There is a metadata associated to it where you can give a name to a pod. Labels will talk briefly. And then it is saying that it is running what kind of container name and the image of the container. So let me take this over here, and I will just write a YAML file for .yaml, right quit. Yeah. So k create from file for .yaml. Awesome. There's something wrong with that. Okay.
I think you missed a line at the end. You didn't copy the image in Nginx.
Let me fix that. Thanks. I will remove this and redo it. U.yaml set. Yeah, this looks good now to me. Yeah, so okay, create .yaml. There you go. So now I got my pod created with name my pod. And if I say key get pods, it will tell me that my pod is there and running with the Nginx image. Let's see what else we can do with this. Apart from that, you can get and you can describe the pod, which will tell you what that pod consists of and what images it is running. And we will go and delete that pod also. So I'll just go take this command and delete my pod. So now if you say get pods, there are no pods running. Apart from single container pods, you can also do multi-container pods. So the example I gave earlier, the same thing, just that you have Nginx in an image for container, as well as there is a log agent. So we can take this also in the example, and I'll say view pod multi-container YAML. Search. And then you say create pod mc.yaml. And now again, my pod is created. Now it has two containers. So if you say get pods, you'll see it is still container creating because it takes time for pod to spin up. But if you run it again, it should be there's something wrong because it cannot get that log image. But anyway, I think you guys got the gist of that. All right, so I will still go ahead and delete pod, my pod, so it doesn't interfere with anything we do next. All right, so that was about pod. Now, how do you identify which animal you want or what kind of products they produce? So when you want to identify these pods, the simplest way to do is basically just stick a label on them. Like in this example, it is there for goat and sheep, there is milk, and then for chicken and ducks, there are eggs. So the way to use labels is basically it's a key value pair, which can be described to one or more pods. The selector is something which you will use these labels to select those pods. And annotation is metadata associated to those objects. So let's see how can we create a label. So now if you look at here in this YAML, again, it's the same construct. You are creating the pod, but there is a label associated to it. It is for production environment, and there is an app called Nginx, which is running on that. So let me take this again. I'll call it labels.yaml. All right. So again, create from file labels.yaml. So now the pod called label demo is created. You can check if it is there. It is still creating the container, but it will be ready soon, I believe. In the meantime, we can look for another command. So how do you pull those pods? Since it matches based on the label values, you can run the command which is checking if the label of environment is equal to production and tier is front end. So you can run that command. It's not found. Apologies, because our app is Nginx and it doesn't match with tier is equal to front end. So let me remove tier is equal to front end condition and just match with this. And there we go. We got our label demo pod running there. So that is the way you can do some more selectors, but I don't want to go too deep into that. Let me close these since we already used them. Go back to my demo. Let me come to another concept. There's something called replica sets and deployments. So replica sets is the thing which you use. For example, you want to make sure that there is n number of pods always running. So for example, you always want to run a certain number of containers for that application. And replica set is the construct which helps you to maintain that minimum number always. And you can use deployment to do that because you don't want to be creating pod and then creating replica sets every time. So deployment is something which helps you to do both in one shot. So let me go to the deployment. And if you look at the YAML construct, it has a kind called deployment. It has a minimum replica of 3 always running for any container or any pod which matches the label for the front end. So let me take this and then create a deployment. So I'll again create a deploy.yaml. Right quit, create from file, deploy. All right, so my deployment is created. Let me clear the screen. So now if I say get pods, you would see since we have given a replica of 3, there are 3 pods created with that deployment. If I say k get all, it tells me everything which is available on the Kubernetes side, right? So we had this pods running. So 3 of them which are created by this deployment. There is a deployment which itself got created, as well as you see there is a replica set. So the deployment created the replica set as well as pods for us, right? So let's try to do something different here. What happens if I try to go and kill one of my pod, right? For some reason, one of the pod, the container crashed. So let me go and delete a pod. And let me pick this one. Okay, there is, what this is telling me is I don't have to give the whole name as pod slash, since I'm already saying it pod. Bit rusty on these commands now. Okay, there you go. So now it is trying to delete this pod. And since we said the replica is going to be 3, so Kubernetes should maintain that. So if I say k get pods again, still we have 3 containers or 3 pods running, because Kubernetes automatically knows that one of them died and I need to replace with it, and always keep that 3 minimum available as a replica set. Any questions so far? Okay, silence is golden.
No question for me.
Okay, let me go forward. Okay, so now we know how to manage these animals, but how do we share some food and water between these animals? There could be some animals who eat similar kind of food, for example, grass. There will be some animal who would eat insects. So the similar concept in Kubernetes, in my mind, is you create something called config maps. So config maps is something for your configuration key value, and it can be shared between multiple pods. Let me go to the config map. So to create a config map, you just you can either create through the YAML, which can say, hey, my configuration data is this is my key and value. So my color is key and blue is my value. So let me go and just create from these literal rather than trying to do it from YAML. So k create config map, and the name of my config map is my map. Let me clear this out. Right. Something is not working there in that command. I guess I had to use YAML. Okay, so basically you can provide the literals for your config map, or you can use the properties file and then it will read it from there. For this presentation, I will go back to the YAML. Sorry about that. So you config map dot YAML. Okay, create from this config map YAML. There you go. So we got config map created. And with that definition, now, if you see, there are multiple ways you can use those config map in your pods or in your containers. So you can say, this is my container and the environment, I'm reading it from this config map. The name of config map is app-config, for example. I won't go too deep into that, but you can do it from environment variables, or you can also mount it as a volumes in your containers. The second concept here is secrets. So just like configuration maps, you can also configure your secrets. Those secrets is very similar to config map, just that they will be base 64 encoded. And I still don't understand why that is a secret, because it's not too tough to decode it. But I think basic idea is they just don't want something to be kept like in clear text. And then you should actually, if it's a secret, I think you should keep it in somewhere more safer, whatever your vault or better safe places, rather than just leaving it around in Kubernetes. All right, so that was about config map and secrets. Now, how do you know that if your animal is falling sick, or if they are not productive and you need to replace them? So there's a construct in Kubernetes called liveness and readiness probe. And as name suggests, liveness checks if your pod is running. And readiness is basically check if your pod is ready to serve. So I can go through that example a little bit. So the same thing for this pod definition, if you look at inside the containers, this is my container name, and then there's the image which I'm using. Now, as soon as the container is created, I'm going and then creating this file called healthy inside the temp folder. And the liveness probe is basically executing the command and then checking if that file exists or not. So it will start checking it first 5 seconds because that's the initial delay second. And then for every 5 seconds, it will check if that file exists or not. I think that is very rudimentary way of checking if something is running or not. But then they have things where you can check through HTTP if some path is running on particular port or not. Or you can also do the TCP check if things are running on particular port or not. The similar thing goes for readiness probe. It's almost exactly same thing. Instead of liveness probe, you will give readiness, and then it will wait for this command to execute till your container is ready to be in action. Yeah, I think it is simple to do it. I will move on to the next one. Okay, this is interesting. So let's talk about volume and volume claims, what those are, right? So we all know that the containers are ephemeral in nature. They will not store the data. And once they die, the data goes away, right? So you can mount your temporary directories within the container, just like you do in Linux. But if you kill the container or container crashes, that data will not be available to us. So similar way, I have analogy here that let's say you want to collect the eggs of duck and hen, and if your duck is sick and then you change the duck, you don't want to just throw away those eggs, right? You want to collect them and keep it somewhere. So that's where the concept of persistent volume and volume claims come in. So the way it works is you create a volume outside of your nodes, and you can create volume claims. So in this example, like hen eggs are my volume claims and my volume is eggs. So I attach my claim to my volume, and I can say that, hey, this is the volume I care about. And then you can attach those claims to the particular pods and containers. Let me get it to the example here. So the way to create it is, so first you go and then you create a persistent volume with this kind of construct in YAML file. Here, if you see, the capacity is given as 10 gig, and then there is this is mounted on this particular path. So then you create this particular volume. Then you create a volume claim. So you claim 3 gigabytes out of that 10 gigabytes. And now you can attach that claim to your pod by doing these kind of volume mounts, right? So if you see here, persistent volume claim, there's a claim name. So claim goes in your pod, which actually gets a portion of your persistent volume. Does that make sense to everyone?
Yep.
All right. Thank you. That brings me to another concept. So now, as a customer, you need a route to get to all these particular containers and then collect all the customer products, right? Now, to get into these particular pods or containers or whatever the constraint area we call it with animals, this person who wants to collect all these things, I call him services, they go across all the nodes, and he has key or the door to get into all these particular containers, right? So there is, and those keys, I call it just the ports. So you do have ports on which your application is running. So your node port in this particular case is 30080. So you know from that port, now you have to get to the particular application which is running on port 80 or 8080. And it could be on one or multiple nodes. So when I open this will probably explain it a little better, right? So you need to do the service discovery in that sense. So what Kubernetes does, it spins up a kind of a Kubernetes construct called service, and this service tells that, hey, this is of type node port. That means on my node, the application is running on this port, whereas inside that node, particular pods who are running on this target port, that's where I'll get that's where I'll route my request to. And there are more concepts to it, but I think this is like very basic of it. So let me go and then try to create a service here. So I'll do view service.yml. Okay, create. And now if you say get all, you see that there is my service is running over there. So now if you are outside of that node, you can hit this port 3008 and you can actually get to that particular pod which is running on port 80. Okay, I think that's the basic I had covered.